So let's do a little bit of a review. Yeah? So when you're talking about a network, what are the little stopping points? Like say you're doing a map and each town is it called a what?
Node.
Node, excellent. Then the roads or the little lines that connect them are called what?
Edges.
Edges, excellent. Good. And remember that the roads leading out of a node, the number of them tells you its degree, right? And the degree can either be even or what? Odd. Okay? All right, so, right? And when we were looking at those, we looked at how to make a chart to show that the nodes and to show if they were even or odd. And that is going to come back into play today, so make sure you know how to do that. We also talked about a path. What's a path? Just from one node to another node, right? And then we also talked about a circuit. What's a circuit?
When it goes all the way around.
All the way around. Good. Start to finish. Okay. Excellent. All right. Well, today what we're going to do is we're going to talk about something called traversibility.
But Mrs. Selby, you're recording.
Mm-hmm. It's all right. It's okay. They all have this low hum in the background. Okay. So, for traversibility, you need to remember the idea of a node and particularly the degree of a node. So, a network is traversable if you can start at one node and trace every edge exactly. So you can go through every single node. You may go through a node more than once. Okay? You may or may not end up where you started. And a network is either traversable or not. So, and you can tell mathematically if it is before you even begin by first just looking at the degree of the nodes, right? So remember when we made those little charts and we had the node and then we gave its degree as either even or what? Odd. Okay. So either even or odd, right? Okay. It's all right. Now, so what we're going to do is we're going to use a pattern or a mathematical pattern that is called either an Euler circuit or an Euler path. And so there you see the name. It's named after a famous mathematician, and it's pronounced Euler, even though it looks like Euler. Okay? And there are two things you need to know. That a network is traversable if it has no odd nodes or exactly two odd nodes. So if you're writing some notes, which hopefully you are, it is traversable if it has no odd nodes or exactly two odd nodes. Okay? So you're going to have to make that little chart to be able to figure that out. Yeah? Okay. And you can either have an Euler circuit or an Euler path. And we just talked about that. A circuit means that you can go all the way around, right? A path means you can go through. So make sure that you know that an Euler circuit can only happen if there are no odd nodes. So this one can make a circuit. Okay? But Euler paths can have exactly two odd nodes. So those are the differences there. So let's just look at the examples they give you there. If you look at this one, it's an even because there are 4. This one's even because there are 2. This one's even because there are two roads out. This one's even because there are 4. This one's even because there are 2. So since all of the degree are even, that means that there are no odd nodes. Okay? And if that's the case, then you can do a complete circuit of those. Right? And there's just an example, but just like the other pathways, other circuits, just like the other paths or other circuits, there can be lots of different ways you could do this. Here you'll see the start. They go through the first node, through another, and then on around. You can pass through a node more than one time, but notice you never picked up your pencil going all the way around the whole circuit. All right? So you were able to do the whole circuit. Then, the other one where you have just a path. We're doing the same thing, but remember that they have to have exactly 2 odd nodes. And what you'll notice there is, if you'll see these 2 odd ones, that you'll always start at the odd ones and you're going to finish at an odd one. Notice that you can't start and finish at the same point when that happens. All right? So that's what makes it a path. It's good? Do you remember? Okay? So how can I tell that it's a circuit?
If it doesn't stop.
They're all, well, how can I tell it's an Euler circuit? I'm sorry. That it has no, what? No odd nodes. There you go. No odd nodes. How can I tell that it's a path? It has what?
2 odd nodes.
Exactly 2 odd nodes. Okay? So what you're going to do is you're going to practice with these. You're going to be doing, going through some of these circuits and listing out if they are traversable or not, and then tell if they're a path, tell if it's a circuit, and build a path or a circuit. This is the skill that you're going to be tested on. Being able to make the determination and then being able to find the circuits or the paths. Then you're going to be asked to use those trees to find the shortest path. So after you've done this lesson, we've pretty much done all of the information that you're going to need to be able to take this test. So from this point forward, it'll be just practice. And we will probably take this assessment.
What do you have to do for it?
We'll look at some practice ones. So we'll probably take this assessment the first week we get back after the holiday.
Oh, but I'm going to forget.
Okay? No, you'll take this home with you. I know you're going to be loving it. All right?